everyone. My name is Kevin.
I'm Frank.
For our final project, we're doing interactive border detection. So border detection is detecting dramatic change in pixel values, and for our real-time border detector, we want to do as camera record. We want to output a gray image, a border lines, color difference, and also save ground detection to a folder, and also window detection. Window is basically a border that outlines the features, like this one shown here, and ground is just the ground and wall. And we want our data set to have obvious ground and window information, so we collaborate with NYU Self-Drive for their image maze data set. We want to navigate through this maze and identify borders using DSP skills instead of any machine learning algorithms. And the algorithm we use for ground detection is we use two masks, basically the color of ground and wall, and they will form a very clear border as shown here. And then we use something called Hughes line transform that will draw a line, and then we will do the intersection in order to get a final result shown here, which we can see the ground is very clearly shown. And for border detection, since border feature inside a window is very messy, so we will use a uniform mask, and then we can see that the windows are blacked out, and then we do some gap fill to make it better, and then we do again use hue line transform to get this result, and so we can see the border are clearly drawn out. Yeah, and here's the demonstration.
And on the top left corner is the grayscale image. On the top right corner is the Sauber filter with gradient calculation edge detector. On the bottom left is the color mask, and on the bottom right is using high frequency filter for the image with 2D Fourier transform, and they all show parts of the edges. And we also save the data for ground detection and the window detection. And here's the results for the window detection. Detects the windows. Here's the result for the ground detection. It detects the ground, and it also shows patches of green data for the pictures because there's a lot of features, but it should be easy to eliminate because they're very different from lines. And we use the DSP knowledges, including convolutional Sauber filter for edge detection. We use HSV values for the ground border detection. We use 2D discrete Fourier transform and high-pass filter for the frequency domain to eliminate the lower frequency of the pictures, and we transform back to image domain with inverse discrete Fourier transform. And this is useful because it saves resources and needs no training, and has applications in frame shift detection, feature locating, and SLAM. Thank you.
Thank you.